Hey everybody, welcome to my latest Foyer tip in which I share my deep and hard-earned and hard-fought-for wisdom on writing PL/SQL code. My name is Stephen Feuerstein, otherwise known as Stephen Feuertrees, because these days I spend as much time among the trees and helping rescue trees as I possibly can, and I hope you will do the same. Anyway, let's dive in on a topic that is freighted, heavy with philosophical meaning. Determinism, fate. We're going to talk about fate in PL/SQL programs this week. Well, sort of. We're going to talk about determinism, not whether or not your life is determined in advance by fate. We're going to talk about deterministic programs, what they mean, how you might want to use them, and so on and so forth. So let's go ahead and share my screen and get rid of the infinity complexities. So, all right. So let's talk about deterministic functions, and let's first talk about what it means to be deterministic. Let's go to Wikipedia. So a deterministic algorithm. A deterministic algorithm is an algorithm that, given a particular input, will always produce the same output. That's really the core of it. The basic idea is that if you look at your procedure or function, it has parameters. In parameters, in out parameters, or out parameters. If it has in, out, or out, and the determination of whether or not a subprogram, procedure, or function is deterministic is when you pass in the same values for your input arguments, what that algorithm or procedure or function does is always the same. So for a function, which will be the focus of our talk today, if you pass in the same inputs, you always get the same value coming back. In a procedure, if you pass in the same inputs, the procedure always does the same things, has the same impact. Now, it's interesting to think about determinism in the context of PL/SQL programming. Let's take a look at that. So now we're looking at some PL/SQL code. Heads up, I'm going to ask you some questions and ask you to respond, and I will give you the opportunity to reply, even if it's painful for me to sit here in silence. So a deterministic function is a function in which, when I pass in the same values, I always get the same value coming out. Here's my classic function I built for actually UTPL/SQL testing and demonstrations starting back in 1999. Between string, it's a variation on substring. Substring says, pass me the string, the starting location, and the number of characters. Between string says, pass me the string, the start and the end locations, and I'll return the string between those two endpoints inclusive. So here's my question. Is this function deterministic? You can answer in the chat. And I'm going to time myself so I don't hurry you too much. I'm going to give myself 30 seconds. So what do you think? Is this function deterministic? No matter what, if I pass in the same three values, will I always get the same value back? I've got a yes. I've got a no. I've got yes, yes. They're coming through. And the answer for this between string is yes. This function, I didn't wait the 30 seconds, but I got some answers. That's probably good enough, right? So the answer is that this function is deterministic. If I pass in the same values, all it does is pass those arguments through to, and with a computation, to substring. And substring itself is a deterministic function. It simply processes the string that was passed in. Okay, that version of between string is deterministic. Is this version of between string deterministic? So time to answer again. Let's see, I've got to start my little clock. Wuta was the last one who said no at 11:03. So is this function deterministic? It's only got one change in it. Line 22 is new. What do you think? Is this function deterministic? It's tricky. I've got some no's. No's, no's, no's. I seem to be getting consensus on no's, and I believe the consensus is correct. So this is not deterministic because I select the number of rows in the employees table, which generally speaking means it's not a deterministic function because it has SQL in it, and then I use that count to modify the algorithm. This is not deterministic. As the number of employees change from call to call to call, I can pass in the same values, get different results back. Cool. Okay, third, is this function deterministic? I don't want count. There we go. Is this function deterministic? This one's a little bit tricky. At least I think so. The answers are coming slowly this time. All right, so I'll answer this one. The answer is that this one actually is deterministic, even though it's got a select statement in it. So in general, if the idea behind a deterministic function is that there are no side effects. That's another way of putting input values in, same input values in, same value coming out, means there's nothing else affecting that function or that procedure. In general, SQL statements, which interact with relational tables, are outside the scope of this function. They usually make things non-deterministic. The reason this one is deterministic is that we never use LCount. In fact, I'm pretty sure that when this function is compiled, if you have optimization level 2 or higher turned on, it will even remove that line of code entirely because LCount is never used. So this will function deterministically, but it's really in general a good idea to never have SQL statements inside your deterministic functions or ones that you're trying to make deterministic. And a lot of people did answer yes. So that was good. Last one. Is this version of between string deterministic? What do you think? Looks like the formula is still the same, but it's using a local variable instead of the parameter. Tricky, tricky, tricky. I got no's coming in, a couple of no's. I think the no's are going to win on this one as well. And the answer is no. This is not deterministic because it has a reliance on what looks to be either a packaged function or it could be a packaged constant or variable. The fact is that there's an out-of-scope reference. This is essentially a global reference from outside the function. Therefore, you never know from call to call of between string whether or not you're going to get a deterministic or expected response. Okay, so very briefly, hopefully that drives home the point of what is involved in being deterministic, that the code doesn't have any external dependencies, or if they do, they don't matter, which would be just bad code. But if you have references to tables, especially non-query DML, like updating, deleting, inserting, if you have references to out-of-scope variables, like package variables, or even package functions, any kind of references, those are also non-deterministic. So one of the takeaways from this little introduction is that most of the code you're going to write in PL SQL as a database programming language is not deterministic, which is good. That's the point of PL SQL, to build layers of code, safe, performant, efficient layers of code around your data structures. So why do we even really talk about deterministic functions? Well, the key reason to talk about deterministic functions, pulling up my notes, and in fact, not sharing anymore. Let's go back to me. So the key reason to think about deterministic functions are three in the Oracle environment. One is that you can create function-based index. And I'll show you an example of this. But basically, if you can have an index that has a function call within it, a function that's called within an index has to be deterministic because, of course, how could you have safe and predictable index values in your index if your result of calling the function is constantly changing with the same inputs? You could create virtual column definitions that call your or other PL SQL functions. They must be deterministic in that case. And if you have materialized views that are query, rewrite enabled, then the functions in that materialized view would need to be deterministic. So there are some specific features in Oracle database that require the use of deterministic functions. The other key advantage, though it's probably overplayed, is that you get some of the same caching abilities that you get with the function result cache. I'll show you an example of that soon. It's not as robust as the result cache. It doesn't offer you as much assistance. It's nice to know about. Probably won't matter that much in your overall application performance. Probably the most important reason to be aware of determinism in your programs and declare them as such, which I'll also show you in a moment, is a conceptual one. Deterministic functions generally are easier to test. You can even do a lot of test automation. I'll show you some scripts to generate frameworks for doing that. It's easier to test and manage deterministic code. Why? Because it's deterministic. It doesn't have all these external dependencies. If I want to test a function that's deterministic, I don't have to say, what is the state of my database? What things do I have to do to set up 1,600 tables with all this data, then run my test to get a dependable result? It's irrelevant. You can just test them in isolation. And related to that, deterministic functions, well, first of all, clearly are then a subset of your code base because they're relatively simple, lacking any external dependencies. Usually business rules, or the core formulas of business rules, can be expressed as deterministic functions. And in general, my suggestion is that you become more and more aware of, or try to be more and more aware of, the code you're writing as being deterministic, and actually pull it out. Segregate your deterministic code from your non-deterministic code. Non-deterministic code would call your deterministic code. Deterministic code can never call non-deterministic code. It will be tainted, infected by the non-determinism. But the point is that you can have a whole body of deterministic code that can be tested more easily and more thoroughly and in a more automated way, can be managed more easily. And then your non-deterministic code, which is your core business logic, all of your APIs to your data sets, can utilize those as separate units that you can trust. So when you focus your testing in your non-deterministic code, you don't have to worry about whether or not the deterministic code is working properly. And in general, the other reason to declare things as deterministic, even if you don't think you're going to get a lot of value out of it now, no performance optimization, et cetera, is that you're telling PL/SQL and the PL/SQL compiler more information about the program. You're saying this program doesn't have any external dependencies, which gives the compiler an ability to use that information now and into the future. Finally, the other thing you're telling about your code when you declare it as deterministic is you're telling future developers that this code is intended to be kept free of side effects. And if you want to do some DML, updates, inserts, deletes, don't do it here. You'll need to do it outside of whatever is calling that function. So those are a number of different reasons or ways to think about determinism and when to use it. Let's go ahead and now look at some code. So Rachel's point, segregated in separate packages, well, I don't know if they need to be in separate packages, Rachel. It kind of depends on how you're organizing your code overall. Generally speaking, for me, a package is organized around areas of functionality. So we're building a little project tracking tool right now, and we'll have a util package, for example. We have a checklist package. So we're doing a lot of checklists around milestones in our projects. We remind people the right way to write code, debriefing from a go to production. So we have a separate package for everything related to checklists. I don't think I'd have an in-track checklist deterministic package versus in-track checklist non-deterministic package. I would have them in the same package, but they'd be separated out. And then you decide whether or not to put them in the package spec, how public you want to make your deterministic programs, or keep them in the package body. Jamal, values are cached, so the function is not executed again for the same input values across different SQLs and sessions, right? No, not quite right. Let's take a look. So let's go back to the code. So what Jamal is asking about is the optimization related to deterministic functions. So let's dive into that one first. And let's first of all show you, take it a step at a time since I've got the script already here. This is an example of using a deterministic function for a function-based index. So I won't go through the script. You'll see in the blog post, and you can see on LiveSQL. But the point is that if I want to create an index that calls a function, like my between string function, that function needs to be declared as deterministic. So it's literally part of the program header. You say, this is a deterministic function, and then you can use it to create your index. In fact, while I show something else, I'll just turn this on. We can go take a look at it. So that's all you do to declare something to be deterministic. You can declare procedures to be deterministic as well. Though my understanding is at this point, they have no value in terms of the processing. Though I suppose if I have a function that's being used in a function-based index and it's calling a procedure, maybe that procedure has to be deterministic. I actually haven't checked that chain of analysis. Here, let's run this code. So what you can see here is that function is not deterministic. I tried to create the index on this with this function call, and it said the function is not deterministic. So it actually checked at runtime for the DDL statement, and it could not use it. Then I redefined it. Oh, and then I have to drop the index. Is that right? It created it, but maybe with an error. Let's see. Let's drop it. I don't do a lot of this. Index. And again. There. So I actually had to drop this index. It created the index, but with errors. I had to drop the index so I could create it in here. But now I can create the index successfully. So that's where the deterministic function declaration is actually explicitly required. And then even if you put it there, Oracle will check and make sure that it is deterministic. In other words, when you compile a function, Oracle doesn't stop you, even if it detects that it's non-deterministic. That becomes a runtime or use time of the function. If you try to use it in an inappropriate manner, then it will detect it. But you can lie. I suggest, as usual, not to lie to your compiler. Let's go over to LiveSQL. So LiveSQL has a bunch of deterministic scripts. I'm sure you're not surprised. Am I still signed in? Let's check. Of course not. Let's re-sign in. Come on, you can do it. Okay, fine, whatever that is. Back to LiveSQL. Search for deterministic. Let's see what we get. Look, I've got some scripts. What a surprise. I'm going to go back to these in a moment. I have code that will generate templates for frameworks for testing deterministic programs. Here's the demonstration of deterministic caching. I want to show performance. There we go. Okay, so what I've done here is create a package with functions that are declared to be deterministic or not based on their conditional compilation flag. So in case you've never seen this before, the $ symbol means that it's pre-compilation commands. I'm saying that if this flag is set to true, then add the deterministic keyword, otherwise leave it out. So I can have one script that works differently under different circumstances, basically the setting of those flags. And then here I have the same thing, deterministic or not. And what I'm doing is logging each time I call the function. How many times have I called it? So then I call it in a number of different circumstances. Oh, this is in PL SQL. This is not what I want. Whoops, let's go back to the other one. That was PL SQL determinism, and that actually used to work and doesn't seem to work anymore. So when we're talking about optimization for determinism, it's all got to do with functions called in SQL. So let's start again. Sorry about that. Here's my good old between string program. I'm putting a pause in the program. So I'm using DBMS, hopefully. I'm not using DBMS sleep because you couldn't. This is a homegrown sleep procedure. It'll sleep for some number of seconds, however many number of seconds I say, 1 second. Then I run it n number of times. So this is a non-deterministic function. I have a cursor for loop. I pass in the same values each time, and it took 9.79 seconds to do this. Obviously, most of that time was spent sleeping. Then I added the deterministic keyword, did the same thing again. And now with determinism turned on, the time went way down, under 2 seconds. Okay. And here I'm now going to take the function call out of my select statement here, call it right here. So it's being called each time. And check this out. The time is back to where it was before. So here's the deal with determinism and caching. The caching that you see here is similar to what you'll see with the function result cache, which I talked about several weeks ago. So the first time this function is called in the scope of this SQL statement, Oracle checks to see if these parameters have been passed to it before. If not, it calls the body of the function. Then when it returns the value, it stores these input values and the return values, same as the function result cache, but it's only within the scope of that select processing. Notice when I called it outside of that select, in its own select, then each time the select statement was executed, it's rechecking for the first initial call of between string, so it runs it every time. So the bottom line is that you do get some caching advantages out of it. You do get some caching advantages out of a deterministic function, but it's going to be rare, I think, that you'd actually see it being helpful, because you're talking about in the scope of a single select statement, you're calling that function. And what's the chance that you're going to be passing the same parameter values over and over again? Probably the way that will happen most is if you're happening to call one of these functions inside the where clause. Now, calling user-defined functions in the where clause can be very dangerous, because it's not being called just for the rows that are being fetched. It's being called for all the rows that are being looked at to determine which rows to fetch. So it can have a really bad negative impact on performance with all the context switching. So in those cases, if you're calling it in the where clause, if it's possible to make it deterministic and declare it as such, then you could see some significant improvements in performance. But by and large, the function result cache is really the way to go. It has a much wider scope of applicability, not just your single SQL statement, not just your session. This is a per session cache as well. So don't get too excited about the deterministic caching. If you get some benefit out of it, great. The only two reasons you should declare something to be deterministic is if it's needed to be, as function-based indexes and so forth go, or it is deterministic and you really want to document that for future use by the PL/SQL compiler or future developers. Judith, why should a function be deterministic for being used in a virtual column definition, considering that virtual column values are not stored as opposed to index values? Good question. I don't know. I imagine it's probably the same rationale as these. So what it will do for you if you declare it as deterministic is give you the advantage of that caching. And it could be that for virtual columns, they wanted to get as much benefit of performance as they can. So they want you to basically enable the caching. I'd say that's a stretch because, again, what are the chances that you're going to have the same values from multiple rows being put into the virtual column? But that's the best I can come up with, Judith, and that's a really good point. Other questions? That's it. Okay, so let's see. Function-based indexes, showed you an example of that. Benefits, right, let's take a look at the benefits of, or the generating the deterministic template. Not to go through all the details of it. Come on, Live SQL, come on back. Let's look at the latest one. So big surprise, I wrote something 6.2 years ago, a unit test template. Then I wrote a generate regression test template 7 months ago. So let's take a look at that. So the basic idea here, without obviously going through all the details, is that you can basically define your test cases. So there's a little array of test cases. And then it will generate a declaration statement, a big anonymous block that will set up your code for all those different test cases. And the basic way that it works is that, I haven't looked at this in a long time, and looks like the color coding is all off. This is all a static string, literal string, and this is the code. Oh, well. So the basic idea is that I find, yes, finally. So what I do is get the argument list for that procedure or function. That's the main thing, right? So you get all your different arguments, and then you generate out calls to those programs based on those arguments. Let's see if I've got some generated code as an example to show you here. Whee! There we go. So here's an example of the generated code for this program. So it's clean Twitter handle. So basically I want to strip out any characters I don't want in my Twitter handle. So it just has the name. Deterministic, right? What you send in determines completely what comes out. And because of that, all I need to do is provide different test case scenarios. Is if it's null, if it doesn't have these values, if it does have these values, which is what I'm doing here, specifying my test cases. And then it generates this code. Now, it's not 100% done. You have to go in and replace values, in some cases at least. But it gives you a lot of code in place to just generate and then modify and run. Should you use this instead of UTPL SQL? I don't think so. But if you're not using a framework like UTPL SQL, and you are in the habit of building deterministic functions, you might take a look at this utility, and there are probably others as well, that will just help you do that kind of comprehensive testing that really is possible with deterministic functions. And if you can take this example, if you can take that piece of code and generate your templates and go to your boss and say, I not only wrote a bunch of functions, but I wrote automated regression test scripts for those programs. Don't tell them you generated most of it from my code. Keep that as a secret to yourself. Just show all the amazing work you can do all on your own and get all the benefits you can from it. Okay, let's see. What do we have? Other questions, comments? Please settle a debate between me and a friend. Is it indexes or indices? I don't know, Rachel. Yeah, certainly linguistically, semantically, either. That's what I'm thinking, that for an index in a collection, it's indexes as opposed to indices. I don't know, is an index physical? And for collections, it can be both. And in fact, there are places where each one is used. Yeah, either way, hopefully that helps a little bit. Yeah, I would say the same thing, Rachel, that when with indexes for tables and indices for books and so on and so forth. Okay. All right. Let's see. I think that pretty well covers it for determinism. So again, to sum up, the concept is the most important thing. Try to get in the habit of recognizing that what you're writing is deterministic. Suck it out. Make it its own procedure or function. Call that as needed. Declare it as deterministic. And then you may get some benefits in performance. Over time, the compiler may start to use that deterministic keyword in more and better ways. And in the meantime, you've added more self-documentation to your code, and you've said to your future developers, keep this deterministic, please. All right, so moving on, I'm going to share with you one of my favorite books. Then I'm going to talk about where we want to send someone, and then we'll get on with our lives. Share my screen, please. All right, so my my cultural artifact of the Feuer tip is called The Tomb. So this is the first book in the Repairman Jack series. Now, I guess it's a horror series. There's a lot of horrible stuff happening. I don't know about you, but I just move right past a lot of that stuff. I don't need to read it. Doesn't matter to me. The Repairman Jack character is hilarious, really interesting, very enjoyable. And I'd at least check out the first book, see if you like it. You can go on from there. I've read the whole series. I got to say, one thing about the series is that the ending of it really does suck. I really wish I hadn't bothered reading all the way to the end because he doesn't go anywhere good with it. But there's so much entertaining parts of these books along the way. So enjoy if you can get a hold of it. I found it kind of hard to get from the library. Not sure why. We're going to this week make a donation to Wild Aid, which is an organization that has a very simple motto. If you don't buy it, it's likely less to be killed. Don't buy it, don't kill it. So the idea is to push back on demand for certain kinds of products made from living animals. They have programs that span many, many different kinds of animals, and they have lots of celebrities to do cool stuff for you. So, for example, they have Jackie Chan doing a little dance showing about pangolins and protecting pangolins. It's hilarious. They do a lot of really great social media and full-on media that have had really big impacts across China in particularly, but in other places as well. So we want to help them help animals stay alive, not be eaten, not be butchered for some superstitions about what their blood or their scales or their skin or their fur might do. Thank you, InSum, for supporting these efforts. So, okay, please stop sharing. That's it for today. Hope you enjoyed it. I hope you gave you a little bit of an escape from not only your job, but all the less than wonderful things going out there in the world. Stay strong, stay healthy, stay as positive as you can. I am struggling with staying positive these days. I have stopped watching the news. I'm no longer going to CNN and New York Times obsessively during the day. I'm cutting way back on my Twitter feed. Who needs it? If I can't change it, and it's happening all the way across the world, I'm going to try not to let it consume me. And I'm going to focus on things that I can solve in my own communities. You two, get out there, be outside, enjoy the world that's not manufactured by humans. See you in a couple of weeks. Take care, everybody.